Good morning. Yes, my name is Pini from Reznik. I'm going to talk about sustainability. So before we actually start and go into the story, first question, how bad are bananas in terms of sustainability and carbon emissions? Any guesses? Like really bad? Medium? Good? Okay, only one believes it's good. Everyone else, they are quite terrible. Okay, you will need to wait until the end to know. So is the climate is actually changing or not? I mean, this is obviously becoming a bit of political issue, and I'm not going really to argue or prove anything. The science says that it is going up, the temperature, right, because of greenhouse emissions. And the only question is if it's going to be a really, really hot or just a bit hot, and that will make a big difference, right? So the main idea is that if we can reduce the green gas emission effect and not get to a really, really bad 6 or 8 degrees increase and only keep it below 2 or maybe 3 degrees, we can make a big difference to the planet. So, and there's sort of like the question how the world is doing right now. It's a mixed situation. On one side, everything is going up, right? We're still increasing our emissions. We're emitting about 55 billion tons of carbon equivalent gases every year. There was this tiny drop. It wasn't tiny, it was 5%. Any guesses? COVID, yes. We stopped traveling and the effect was 5% reduction. And the year later, we picked up and overgrew that, right? So that wasn't really a solution. So basically, all the developing countries are going up. The good news is that all developed countries are going down, right? They're past peak for some of them for 20 years. United States going down, European Union going down, Switzerland is going down. So actually, we are past the amount of carbon gas emissions we are on average emitting, even though the economies are growing, except the China and India and other big countries are still growing. Actually, China stopped growing, but India is growing. So we're still in big trouble, right? So still the emissions are going up. And in terms of energy, so we are still consuming the most carbon-intense energy of oil and gas compared to ever in human history, right? So it's still the top, but the good news is that the actually green energy is going significantly to grow, right? And the main reason for that is because the cost of solar and wind energy is actually below the oil and gas, and that's the best driver. So it's not the regulation or other things, it's really the cost. So we expect that this black part is going down to about 10% of current consumption by about 2050, right? Which is obviously estimations, we don't know for sure, and the green part, which is wind and solar, will explode, and the others, like nuclear, probably will stay the same, but we don't really know. But the good news is that there's a lot of optimism, but the question is how much we're going to emit until we're going to get rid of oil and gas. So we all sort of think, I thought when we started Reznik a year ago, I thought that the governments are actually going to play the most important role in driving this change. And they are, some governments are. European government is the most advanced one. There is a EU Green Deal. There is a demand to reduce carbon emissions by 55% by 2030 and by 90% by 2050. The problem with it is that there is no actual demand to reduce anything at this point. The only actual regulation is to report the emissions, but there is no target for reduction, and there is no fines or taxes or or credits or anything like that to actually encourage or discourage to emit more or less, right? The only thing that companies need to do, larger enterprises, is actually report how much they are emitting. And larger companies need to do it now, and smaller will need to do it later on. And Switzerland is pretty much aligned with the EU today. Right, so it's very similar. It's not exactly the same, but it's very similar, apparently. The other countries that are doing any sort of regulation is UK. There are some countries and some states in the US, like California, but everyone else, more or less, there is not much happening. So there is not that much regulatory pressure to reduce emissions. So, and there is, on the other side, there's a lot of talking, right? A lot of companies say that they are green, while not actually being that green. There are many, many, many ways to do it. The most common one is just tell people that we are greener without any support whatsoever, right? Without actually doing anything. It's a very easy thing to do. The only thing you need is PR, and yeah, there's no actions required. There are actually a bit more difficult things you can do, like there are different scopes of emissions, so you can only mention scope 1 and 2 and not 3, whatever it means. You can sell your factory to somebody else and then not include the emissions from that factory in your reports. There are many, many ways to talk and not do. A very common way to do that is buy carbon offsets for quite cheap. It's about $80 per ton today to offset your carbon emissions. If you fly, you can pay as little as €5 to offset your flight, which is not really true, right? If it would be that cheap and that easy, everyone would do that, right? Except we don't have that many forests to plant, right? And we don't have those technologies. This money is not really going to good causes, most of it. And this very good video you can watch if you like by John Oliver. It's 20-something minutes, and it's actually really good. It's if you still want to do carbon offsets, watch the video you want. Okay, so all that was sort of generic, right? So in the world of like the entire planet, how the companies are doing, but what about us as IT, right? That's what we care about. Now, this is the current state. One is the current state, yeah? So this is the regulation. It's going down, so we need to reduce by 50% by 2030 and by 90% by 2050. In the same time, the demand on IT is going to grow. It's expected to double by 2030 and tenfold by 2050. When I say the demand on IT, I mean AI, digitalization. Everything becomes digital. Everything becomes computerized, right? So we are building data centers. We are building edge devices. We are embedding things in everywhere, right? So this represents the growth of IT industry, and this, the emissions, right? And already you can see that when you build a new data center, you cannot really connect it to a grid because there's just not enough power, not enough energy. Most of data centers build their own energy supply, either green on the roof or not so green with diesel generators. And there is a serious problem here, right? So there is a demand to grow, and in the same time, demand to reduce emissions, while there is no detachment really. Like at this point, when you want to increase the demand or supply of IT, you also need to increase emissions. In the same time, an average business today is only using 10 to 20% of its IT capacity. Who can't recognize that? Who disagrees with that? Yeah. So there's obviously some weird disconnect here. On one side, we need to reduce emissions, and then we are just 80 to 90% of our IT capacity in the cloud, on premises, everywhere is just not utilized at all. So if we talk about enterprises and larger companies especially, so there's a variety of different reasons nothing really happens. There is not enough regulation. There is the part of IT within the whole organization is typically marginal, so there is no point to invest in it. There is no available data, no available experts. There's so many different things. And at the end, it's basically everyone really, really wants to reduce emissions, but they want to do everything else first. So currently, sustainability is not going down to engineering operations. It stays typically within marketing and finances. So there's actually no active actions. And although there is a lot of talking about sustainability in typical enterprise, there is not much of actual reduction. That's the current state that we experience in last year. So what we figured out in the last year that we need to reframe the question, because companies don't, I mean, everyone wants to save the planet, right? It's just a big difference between wanting to save a planet, right, and actually spending a lot of money on changing Kubernetes clusters to save the planet. So the way we see it is that it needs to change from saving the planet to value creation. That's what companies care about today. So this is a book I wrote 5 years ago, which was based on 20 years of experience in IT and 5 years of consulting in cloud-native transformation, or helping companies to adopt cloud-native technologies. And a general idea of the book, and this is 5 years old book, right? The general idea of the book that most companies wanted to use cloud-native, didn't know how, and then there's a variety of problems in actual transformational process. And what we were advocating is slow transition. Define a strategy to move to cloud native, build a small team, build a few POCs, MVP, and then gradually scale up the cloud native environment, make it more mature, build stable environments, and then gradually ramp down the old stuff, the legacy. There's a bunch of design patterns and whatever. This is not the topic of the book, but this is from the 5 years ago when majority of the businesses wanted to adopt cloud native, and mostly because they thought that it would allow them to go faster. All this is based on this model, which is maturity life cycle of everything. It's not particular product or initiative, it's everything. Everything we do starts small, gets to maturity and dies, right? We as humans, the same thing. Typically, the research part up front left behind, but I'm mentioning it still. So the goal is to get here. Most businesses want to be in mature state, delivering profitable value to the customer, right? That's the goal of every business. And once in a while, there is a significant transformational change or new product or something like that that requires big changes. And we always need to be on the lookout for new ideas. And every of these stages is different, significantly different. And when we start from research, it's all open, tiny teams, skunk work style, just doing whatever they like. Everything is manual. No one really cares how it's done. It's done in sandbox. It doesn't affect any production. So it really is as free as possible. It's all about ideas. But as we go to maturity, it's all about performance. So as we go through transformational stages, it's agility, change direction, create new things. But as we get to maturity, it's about focus and delivery. It's about quality and stability. Right? Not going to go too much into this, but what happens when the product matures, and I consider transformation to cloud native or adopting cloud native technology as a big initiative, big transformational initiative. As this initiative matures and becomes more stable and grows across the organizational culture needs to be adjusted accordingly. What happens if it's not done? So when you do research, it's great in the beginning. The initiative is early in the research stage, and organization is skunk work. But if you keep going like that without adjusting, then you get to Wild West and hero culture. Who recognizes that? Yeah, so no order, just random people doing random stuff in production. That means that this initiative never matured, processes never were introduced. On the other side, when you have a mature organization, typical enterprise, and they try to innovate and go into research, they do death by committee and innovation by bureaucrats, all kind of things that are just like, let's put 50 people and plan the innovation up front. Never works. So basically, we are in this new curve always starts in two points. Either there is a new initiative from the beginning, like you are a startup and you start a new thing, or when there is a new transformational change, when something changes, the architecture changes so significantly that due to Conway's law, it also requires organizational change. And that's how the cloud-native transformation is. It's so significant. We changed from monolithic to distributed architecture, which also requires adjusting organizational structure. And this is called disruptive innovation, but we still continue doing sustaining innovation as we go, right? And this is constant process. Yeah, so my career started about here, and about end of mainframes and beginning of monoliths, or whatever you want to call them. There are a variety of different names. What happens today is that most companies are somewhere here, either just before starting cloud native, or most companies actually already have something cloud native. How many companies don't have Kubernetes? You have to have Kubernetes today, right? You must. Which is about here. And there are few companies that are really advanced. And it's not just Google, Meta, and those, because they were actually born cloud native. I mean, there are just other companies that they went through the process and became so mature that it actually works well. They actually have very well-defined processes. So most companies are somewhere in between here, and the next stage is probably something around AI. And I'm intentionally not going into details, but just a few words is that I'm not talking about AI in terms of generative AI to write blog posts or create images. That is happening for sure. What I'm saying is that whatever is currently done by DevOps or platform or whatever other engineering teams is done manually or semi-manually automated in algorithmic way, right? So we define those algorithms, how to schedule things. This is potentially going to change towards AI. So we will use AI to generate compute systems and manage them, so which will allow us to scale even further. How it will look like, I don't know, right? But that's exactly how we started cloud native. So we started, as my previous company, Container Solutions, we started cloud native journey in 2014, just after Docker started. And it was about, the world was about here, and just beginning of cloud native. It wasn't even called cloud native then, right? That's why the company was called Container Solutions and not Cloud Native Solutions. The point was that no one knew how to do it, so it was all about research and innovation, trying different things and exploring. And that's what most companies should be doing now about AI, exploring, not really moving to AI. Okay. I keep talking about maturity and, and different things, how it actually looks like, how a mature cloud-native environment looks like. So this is sort of maturity metrics aligned to these stages. Yeah? And if research stage, again, it's very open. Yeah, the goal is to innovate and learn, right? In safe, detached environment as quickly as possible. No planning, no specific goals. You cannot say to a small team of researchers what they're going to figure out, right? Because that's sort of opposite to the logic. Yeah, the whole point of research is to figure out new things. You need to give them the freedom to do that. And for that, there are very few rules. There is some sort of lab setup in a sandbox, and everything manual, no automation, nothing really particularly difficult. What is difficult is for managers and enterprise to allow this to happen. That's what's difficult. And then there is maturity. A mature state is all about optimal operations. It's operational excellence. It's numbers-driven, with traditional rolling budgets, with operational metrics. It's lean, not agile. And I'll talk a bit about this, the difference between those. With specific specialized teams and modular architecture and continuous delivery, if you can see here, it's all about automation, numbers, and processes. And then there is in between, once you decide that cloud native is the right thing or something transformational is the right thing, then there is a transformational part, which is agile. That's where you start developing things, and there's some sort of milestones and agility, so ability to change direction, and cross-functional teams. So there is no actual structure. The structure is introduced as we go, as we figure it out. Right? And then I'll just quickly sort of go through the tools we already have to achieve maturity. So this is, Google is using this. Actually, a lot of examples are driven by Google because they actually are mature organization and capable of innovating. So OKRs is numbers driven. Right. Again, without going too much in details, the planning can be, so a lot of companies actually don't do strategy, unfortunately. They just sort of go forward with a lot of planning, but without a lot of strategy. And this is a good way to do it. Specifically, I wanted to focus on agile and how agile is actually more of a problem than a solution in many ways. When I started my agile journey in early 2000s, I was taught that there are 3 key points to agile. I mean, obviously, this is waterfall, periodic releases, and the tiny releases of agile. And the first one is quick feedback, right? This is very valuable. When you build a new thing that no one knows, then you want to quickly put it in front of a customer, get feedback, and adjust your work according to that. The second thing, all these areas, sooner you release the value to the customer, sooner you can charge them for that, right? That's more revenue, that's more value, sooner delivered to the customer. That's pure profit. And then the third one is discipline to maintain high quality of short releases. The first one is relevant for agile, for change in direction. But what if this is sprint 150? Are you still changing direction, right? How many have here passed like 100 sprints? How the ceremonies look like? Are they exciting? Are you changing anything? And why do you do those meetings, right? I mean, are they not useless? Yeah, and the whole point of people talking and sitting in the same room and talking to each other so they can address the problems immediately. But there is no change. There's consistent delivery of similar functionality. So this is not working. The other two are actually very relevant for a different methodology, which is lean. Yeah, lean, which is a regional Toyota production system. If you think about producing cars is not agile. You don't change direction when the cars are flowing through the conveyor belt, right? It's operational excellence to deliver the same car over and over again at highest quality with minimum errors, because errors are cost, right? They are generating the cost down the line. So the lean is all about operational excellence, while agility is more for research and development. And if you look into Agile Manifesto, that's exactly what they say, right? They say we value individuals and interactions, working software, customer collaboration, responding to change. This is agility. It's all about times of change when we need to create something new. But when we are in sprint 150 on mature product, we actually need processes and tools, comprehensive documentation, contract negotiation, and following the plan. This is lean, right? So what needs to happen is actually transition from this to that over time. Because being an agile is like, anyone here recently renovated a house? Can you imagine living in constant renovation for 10 years? Is it a good thing? It's painful. You want to reduce it. Reduce the length of renovation so you can move into the house and live in stable house, right? Stable, high-quality house. So I heard from, I was doing something similar a few weeks ago, and somebody from a big bank told me, but this lack of stability is like cost you pay for being agile. And that's just sad, right? And disappointing, right? You don't have to pay this cost. You can actually be better. So, okay, moving away from agile, so there is a lot of actually approaches and techniques and technologies that allow us to be much more mature. Like SRE metrics. Everything around SRE is about putting specific numbers in front of operational numbers in front of managers, developers, and operation teams, and helping them to systematically improve the quality of their application, reduce the toil, and making everything better all the time. This is happening in mature teams. And I'm not talking about sysadmins that were called DevOps and now called SREs. I mean SREs with the error budgets and SLOs and SLAs. In terms of sustainability, there are similar numbers that can be achieved. They are not easy to get to actually collect, but we can put together numbers that we can use later to achieve consistently get better in sustainability and reduce our carbon emissions. FinOps metrics, it's again all about operational metrics. DORA metrics, it's about productivity of developers expressed in actual numbers. This is not agile, right? This is way more lean. This is all about maturity and predictability. And the biggest part of it is a platform. I'll go quickly through this. So the general idea of a platform is when different users enjoy of other users being present on that platform. And they're force multipliers, so they help. When somebody does something in a platform, everyone else benefits from that. Right, there are a variety of different platforms. We typically talk about internal development platform, right, with CI/CD and stuff like that, which is shared across the organization. We talk about base application platform, so where we have cloud platform that different teams can use it. The variety of different data, AI, business, different platforms. There's a variety of different platforms. The main function of a platform is to hold high-quality, reusable components that can be used across the organization, right? So the qualities of good platform, it just works. Yeah, it works. It's built with product mindset, so it releases new features. It's reusable. It's efficient. So security, sustainability, all kind of things, you all put in a platform. And if you use the right platform, then you get them sort of free out of the box, right? What happens when different teams use different components? It's the opposite, right? Everyone is doing something else. That happens when you have an organization that they give their team leads credit cards to buy cloud services. That's amazing for innovation in early stages because they can try different things very quickly and they're not bound by organizational bureaucracy. But as they go and mature, now you have 25 different platforms, right? 25 different setups across the organization, all entirely different. Most are not optimized, not secure, not performant, and no consistency, right? Have anyone seen anything like that? Like more than 3 platforms doing the same thing, yeah? I have seen a really large organization with 9 platforms, and they were supposed to be doing exactly the same, all very different and different quality. There is, and I'm not saying that there is no value in innovation and different people using appropriate tools for whatever they're doing. But at some point, it has to become more stable. There's a lot of ways to measure performance. Again, it's all about numbers and metrics. And when we introduce platforms, it also happens very gradually. There is some application, doesn't matter what. Typically, there would be development platform first for one product, and then there's some sort of infrastructure platform, and then different products sort of join the platform. But then they start contributing to it, and then others enjoy it, and there is some sort of consistent push of stable functionality towards platforms, so your time is free to develop new value, and you don't need to deal with all these issues all the time. And it keeps sort of growing, and eventually, the idea is that this part below becomes the stable thing. That's where Meta, or Facebook then, originally said, we want to go fast and break things. In 2014 or so, they said, we want to go fast and stable infrastructure. That's what they meant. Building the platforms that are stable and choosing to going fast on the product level when the innovation actually happens. And we adjust the teams to that. So the teams are not anymore DevOps or cross-functional. The teams are actually more specialized, just in a new way, with team topologies. Right, so the general idea is that if you ask what should I do if I'm an enterprise and I have sort of semi-functional cloud-native setup, what should I do? Is keep pushing towards the maturity. Right, finish the cloud-native transformation and make the setup stable, high-quality, performant, so you can free your time to the next thing. And then in a mature state, that's where the real value created. That's where the real scale happens. You don't have to sort of give up and stop in the middle of transformation and accept the agile mess as actual goal. And just a few minutes, a bit about current state of IT, measuring emissions in IT. So first, when we measure emissions in IT, and it becomes just a bit more technical, but I don't have time to go fully deep in technology. But basically, reducing IT reducing carbon emissions in IT, there are three elements to that. One is energy efficiency, so how much energy a computer consumes. Second, hardware efficiency, so how much hardware, pieces of hardware we consume, so because each piece of hardware has embodied emissions, right? The emissions that were generated when the device was produced. So by the time you buy it, they already emit it. And then you want to sort of spread it across the years of use. And carbon awareness is what kind of energy are you using? How green is it? And we can't just overnight become green, right? That's what people don't fully appreciate. It's enough to take the first step, right? It's enough to start measuring the emissions, right? Understand how much energy you are consuming, how many pieces of hardware, how it translates to carbon emissions. And only over time you can sort of gradually invest more and more in sustainability and become much better in that. And currently, there are only few tools that can actually allow you measuring the emissions. And I think any reduction has to start with measuring, right? Because how can you reduce if you don't know how much you're actually using? So the one which is the most, the best tool available for, and it's most appropriate for this conference is Kepler, which is, it measures energy consumption within Kubernetes cluster. It's actually very good. It's quite difficult to maintain and install. It has agents on each Kubernetes node. But it's great. Yeah. Another tool is called Scaphander. It's very sort of similar to Kepler, but it works on on-prem environments. Now, Kepler only does things inside Kubernetes, not outside and not below Kubernetes. And it doesn't convert it to emissions, but only to joules and energy. Scaphander is sort of similar, but it cannot run in the cloud because it needs access to physical hardware. We built this open source tool called Ether. So the general idea was that we want to measure emissions in real time based on actual consumption, but not just for Kubernetes. So we built a tool that connects to OpenTelemetry, and whatever information it collects, it figures out what kind of hardware there is below and what is the energy, how that hardware consumes the energy profile, and then goes to something like electricity maps, it converts it to emissions. So this is quite simple tool. Now, I'm not really saying, like, you can use any of those tools. It doesn't matter. The point is that there are not that many available, and it's important to measure emissions, not in terms of spend, how many euros have I spent, or francs I spent on my cloud services, because that's actually not a good measurement. A good measurement is to actually understand how much energy is spent on specific parts of the IT, because that creates, even if it's not perfectly accurate, it gives you the right trend that you can, over time, improve. And in our experience, if you do measure and you want to improve, the easiest way is to get 50 to 70% reduction of emissions is just reduce the waste. Right, the simple things like zombies, right scaling, using cloud instead of wasteful on-prem. Many companies have Kubernetes but don't do auto-scaling, or if they do auto-scaling, they only scale up, never down. Switching off testing environments, switching off unused hardware, switching off servers. When you switch on a server and you don't use it at all, it still consumes 20 to 40% of the total energy. So there's a lot of things you can save without any effect on any functionality or any significant extra effort. And then beyond that, there's of course you can improve the code. You can trace everything inside your application and go in really details. I wouldn't recommend to start with that because the value there is not that much. If you consider 80% is wasted on infrastructure level, there's not much to save here, but it's fun. And there are a bunch of talks that you can watch if you want to know how to do it. This slide always creates a lot of noise, like which programming languages are better. Yeah, some are better than others. But this is waste of time. I mean, there's some can be replaced with some internal compilers, and there's all kind of ways to go around it. And again, most of the waste currently is in infrastructure anyway. Right? This is electricity maps. You can move your loads from one location to another. Switzerland is actually quite good. You don't need to do much. But if you are in Poland, you can move to Norway. Or if you're in Netherlands, you move to Norway, your loads, but then you use the Norway electricity, and then instead of streaming it back to Netherlands, because if you don't use it in Norway, they will stream it back to Netherlands. So it doesn't really help anyone. Right? So you really need to think on a bit bigger level how it affects the entire world and not your particular emissions. Because in your reporting, if you move from Poland to Sweden, you're great. In reality, you're taking somebody else's green energy, and then likely you need to have a setup that is duplicate setup of hardware, which creates carbon emissions, embodied emissions, and all kind of other problems. So it's not always a good idea to move locations. And then there's embodied carbon. A physical server takes thousands of, tons of emissions, and if we extend the lifespan of servers, we can make a lot of money and also save a lot of emissions, right? So that's basically the last thing, which is most of the saving currently is done on infrastructure level. You can do a bit more on the software level, but just reduce the waste. That's the main recommendation. And the last, I do have half a minute. Bananas actually not that bad. Actually, they're quite good, right? This book is actually very good. It explains where the emissions are and how much each thing emits. I think the main point for me to show it to you is that most people don't even know what's good and bad, right? We don't really, if you want to take a picture, this one. Yes, so just a few other examples. Cryptocurrencies use up to 0.25% of total world emissions, mostly on wasting energy. Total emissions of IT is about 4% and expected to grow up to 14% if we do nothing about that. Right? So we have a lot of things we can do immediately without actually affecting much the outcome of our application. And the main recommendation is just reduce the waste and create mature environments. And that's it. Some recommended books if you like. Thank you. Questions? We have 5 minutes for questions, I guess, right?
Thank you so much, Pini, for this important topic. Are there any questions for Pini? Back there. I can't throw that far. Can we do a chain of throws?
Thanks for your talk. I was curious if you have thought about what the consequences are with the current hype around AI regarding infrastructure, because everyone either is in the cloud or a lot of people are also trying to build it on-prem. And I assume that's a big impact, right?
So impact of AI is big, really big. Yeah, a couple of examples. Microsoft announced, 5 years ago that they're going to be carbon neutral by 2030, and they were on a path until they got OpenAI, and now they're 30% up in the last 2 years. And I'm not talking about a tiny startup. I'm talking about entire Microsoft, yeah, adding 30% to their emissions just because one AI company. So this is only beginning. We don't even know how far it will go. And it doesn't seem to be that there is a lot of optimization going on. I mean, there is a lot of optimization in different ways, but not enough, right? Companies are training massive models. Not often they don't need to do that, but they do that because they don't fully understand what's going on. The GPUs take sometimes triple the energy of CPU, right? And companies buying tens of thousands of them. I mean, NVIDIA producing them as fast as they can, right? So I don't have a clear answer, but it's not going very well for climate.
Thanks.
Thank you. Are there other questions?
One more.
Over here? Nice, thank you.
Hi. So in the beginning, you mentioned like governments are taking some actions, or they're proposing some goals to reduce emissions. But then you said they're not really pushing for it, or at least they're not putting the right incentives to really force people to move. And usually it's cost saving that's making companies do something. Do you think that we're missing something there to help us move faster?
So first, I also don't think that cost is the right driver. I think most companies, especially those moving to cloud native, they don't really care about cost. I don't think so. I think what they care about is innovation, is ability to, or competitiveness and profitability. That's the real goal. Cost is the profit comes from revenue and cost is the boring part of getting to the profit, right? So what they really want is to get more revenue. And sustainability is perceived as the thing that goes against that. That's why there is resistance. Now, the governments, that's what they do. They fight the resistance. They force companies to do the right thing. But at this point, I don't feel that there is enough regulatory pressure to actually do that. I think, there are no practical, no carrot and no stick, really. Yeah, so there's only reporting. I think government should be doing more, but it will take forever because they are, by definition, very slow. So I don't have an answer, but that's why our messaging is shifting away from, shaming people and doing the right thing towards explaining that sustainability is actually not a waste, not an investment, but it actually immediately brings more revenue and more profits. Because majority of the improvement in sustainability can be done first by, saving cost by reducing waste, but the real thing is not even that. If you think about the mature systems, it's not about saving costs. It's about it's about speed of delivery. Companies like Google, like those fast-moving companies, those processes, they allow them to deliver value, create value faster and more efficiently. That's the real value. right? So the sustainability is a side effect. Good processes are good for other things. That's what we argue now. Yeah, so if you have mature environment with clear continuous delivery, when you shut down the things, you don't ignore issues, you don't increase the VM size instead of addressing the real problem, you don't just get lower cost and better sustainability, but you get higher quality systems that can deliver more value. That was a long answer, but hopefully clear enough. Thank you.
Thank you a lot.